This is lesson 12, activity 3, congruent pairs. And this is part 2 of congruent pairs. And so once again, you are going to be given two images and asked whether or not those two images are congruent. In the first case, you have image A and image B, and they are congruent because you can map them. You can get them to lay right on top of each other using a rigid transformation. In this case, two rigid transformations. So you can translate A 7 units to the right. So 1, 2, 3, 4, 5, 6, 7, and then rotate A 90 degrees, and it will map to B. All the corresponding points will match up exactly. So A is congruent to B. Now, rather than doing two transformations, a translation and a rotation, you could get from A to B by doing a single transformation, which is a rotation. So if you can find the center of rotation, then you can do a single transformation, moving A to B by that, through that rotation. So to find the center of rotation, I'm going to do this in Docere once again, connect the corresponding points. So for example, H connects to Q, find the midpoint of that line that connects the corresponding points. And if you, in Docere, if you just draw a line and you bring it close to this line and you move it along, eventually it will snap right here to the midpoint. And then you can draw a right angle, a line that's perpendicular to HQ. And if you draw that line, it will go down here. And if you do that with several of these points, you'll find that they intersect at the center of rotation. Now in Docere, I left all of the tools in Docere so you can see what I'm doing here. What I'm showing you is that to draw, you can draw a right angle. So draw a vertical line. So if you start drawing a line in Docere, so here's the line tool right here. As you start drawing that line in Docere, and if you tap a second finger to the screen, it will snap to a vertical line. So that's a way to draw a vertical line, and the same with a horizontal line. So if you start drawing a horizontal line in Docere, and then you touch a second finger to the screen, it will snap to a horizontal line. So now you have a right angle. You can use that, so you can copy that and paste it back into this figure, rotate it around, put the intersection of the right angle at the intersection of the midpoint here. And so the side that comes off of this and goes in this direction, that'll point you towards the center of rotation. You do that with several of these, and you find that they all intersect at the center of rotation, and that shows you the point around which to rotate A, in this case 90 degrees, to get to B. So A is congruent to B. The next image, A is not congruent to B. So if you look at these, you're going to see that they have different lengths. Actually, this is 3 units and this is 3 units along the outside. These look like reflections. So if you were to slide this up right next to this, you'd find that this is 3 units. This is the score. This is the corresponding position. It's not really a corresponding point because it's not congruent, but it's at the corresponding position to G. So it's 3 units, 3 units. It'd be 3 units down and 3 units down. But then the sizes change. This is 2, 1, 1, 2, whereas this would be 1, 2, 2, 1. So if you actually listed those lengths, starting at G for this image and moving clockwise, so this is 3, 3, 2, 1, 1, 2. And then you listed the same corresponding positions. Now this is reflection, so you're going to start at R and move counterclockwise. That's why it's CCW here. Counterclockwise instead of clockwise, because it's now you're looking at a reflection. So this is going to be 3 units, 3 units, but now it's 1, 2, 2, 1. So now you have different lengths in the same corresponding order. kind of a weird way of saying it, but this is the corresponding order, counterclockwise, to this order, which is clockwise. But you have different lengths. And actually, this reveals what the authors did to change this image to this image. What they did is they switched lengths ij and jk. They just flipped this down here and flipped this up here, and they switched the same lengths. So it is, here's the same thing over here. I'm sorry, to get to this image, they switch the positions of those lengths, and so they end up that this is now 1 unit going this way, and this is 2 units going up and down like this, going vertical. And I'm kind of mixing this up, sorry. They did the same thing here. Let's see if I make this a little bit more clear. In this image over here, it's 2 units. This one's 1 unit, and this is 1 unit in this way, and this is 2 units along this side. And so they switched them. So this was 1 unit, then it became 2 units, and this was 2 units, and it became 1 unit. And so down here, I put the blue dots here to show you they switched the 1 and the 2. So it became 2, 1. It was 2, 1. And they switched the 1 and the 2 here to make it 2, 1 in this one. And I'm making a mess of this, but this is 3, 3, 1, 2, 2, 1. And this is 3, 3, 2, 1, 1, 2. So they switched these two to right here, 1 and 2. And they switched 1 and 2 here to these two, 2 and 1. Anyway, all of that is trying to say that image A is not congruent to image B. And in the simplest case, you can just look at them and tell that they're not the same, that they're not congruent. All right. The next pair, image A is congruent to image B. So you can translate image A down to here so where it lines up. So JG lines up with PQ. So if you translate this down 1 unit and over 3 units, and then reflect over this line of reflection, which is right here, image A will map to image B, so it is congruent. So if I translate image A down here and then reflect it over, now remember in a reflection, you're going to move the corresponding points over the line of reflection, which is right here, is PQ in this figure. And you're going to move them at a right angle to this line of reflection in equal distance on the other side. So H goes to R and I goes to S. Q and P are the same as J and G. Once this translates down, they cover each other, they map together. So they are congruent. You have a translation and a reflection. The next image, image A is not congruent to image B. The sizes of these angles are different. The side lengths look like they might be the same, but the sizes of these angles are different. They're not 90 degrees. So in this square, all the angles are 90 degrees. In this rhombus, you have angles that are larger than 90 degrees and 2 angles that are less than 90 degrees. So these 2 angles that are opposite each other in a rhombus are equal. This angle is equal to this angle. And these 2 angles that are opposite each other in a rhombus are equal. This angle G is equal to this angle I. And in a quadrilateral, which has 4 sides, all of the angles will always add up to 360 degrees. That's easily seen. If you have 4 times 90, that equals 360. But in a rhombus, this angle here, if you add this angle to this angle here, they will add to 180 degrees, half the number of degrees for the angles of a quadrilateral. And these 2 angles will add to 180 degrees. So what I did here is I drew right angles. If you draw a diagonal here, and then draw another diagonal here, those two sides together equal 90 degrees. They are a right angle, because if you move from this diagonal to this midpoint right here, that's 45 degrees. And then from this midpoint to this diagonal right here, that's another 45 degrees. So together they add to 90 degrees. So I did that in both cases. So the red angle in both cases are 90 degrees. And actually I moved that red angle down here, rotated it around just to show you that in fact it is 90 degrees. But notice then that the blue angle, angle H, is a little bit larger than 90 degrees. It goes beyond in both cases. And angle G is a little bit less than 90 degrees. In both cases, it doesn't quite open up to 90 degrees. So it's a little bit less. But these two angles have to add together to equal 180 degrees. So this blue angle, angle H, is greater than 90 degrees by the same amount that this angle G is less than 90 degrees. So you put them together, they add to 180 degrees, so they are supplementary. So I copied them down here, and then I rotated angle H around and lined it up with angle G, and you can see that they form a 180 degree angle. They form a straight line because they are supplementary. They have to add together to equal 180 degrees. But notice that angle H, the blue angle, is greater than 90 degrees, and angle G, the pink angle, is less than 90 degrees. It's a rather involved way of just showing you that those angles are not 90 degrees. Just trying to show you a little bit more detail of the geometry. But in the end, image A is not congruent to image B. And the last one, image A is also not congruent to image B in this case as well. All right, so if you look at length PQ, it's a diagonal of the square on the grid, and then another diagonal of the square on the grid added together. So these are two diagonals added together, so that's the length of PQ. And so if you go over here, that same length is right here. This is the diagonal, another diagonal. So together they are a diagonal of a 2 by 2 square. So this is the length of PQ. But notice what happens to the length of the side length of A, which is J to I. That's the radius of this circle. So if I draw a circle and make the radius JI, I can rotate that all the way around. It's always going to be the same length. Well, if I line it up right here, the radius, notice that radius is a little bit longer than what the length of PQ is. So the side lengths of the squares do not match, so they are not congruent. The sides of A are a little bit longer than the sides of B. Now, another way to show this is to look at the area. In activity 11.3, we notice that if the area of two rectangles differ, then those two rectangles cannot be congruent. Well, a square is a rectangle, and if the areas differ, they cannot be congruent. Well, the area of square A is 9 square units, or 9 units squared. It's 3 by 3. You can actually count them. You're going to get 9 square units. For B, a little bit harder because it's rotated, but there are 4 square units, but then each of the colors add to another square. So this is a half a square, and this is a half a square. So these two orange triangles add to a whole square. These two purples add to a whole square. These two blue triangles add to a whole square. The two green triangles add to a whole square. So this is 1 unit, 1 square unit, 2 square units, 3, 4, 5, 6, 7, and 8. So the area of B is 8 square units, or 8 units squared, same thing. And the area A is 9 square units. And I thought it was interesting just adding this little length of the side for A, added an entire another square unit to the area of square A. Just that little length right there to the side. All right, so corresponding pairs. This is part 2, activity 12.3.